Hello everyone, I'm Fyp from Faculty Engineering. I am going to present my final year project, which title is Utilization of Reinhardt ash and silicon rubber in the production of mature fire-resistant geopolymer coating composite using response service methodology. There are some introduction about this study. So there has three objectives for this study will be investigate. And the first chart shows the sample preparation, and there are the material used for prepare the sample. In this case, the ratio of AA solution is fixed value, which is 5:5, and for the amount of RHA and the silicon rubber is forward to the experimental design. So this is the next step for prepare the sample. Actually, in this study, there has two patterns on sample will be prepared for each fire test and mature test. For the fire test, the mixture was coated onto the surface on my steel plate and evening spray. But for the mature test, the mixture is poured directly onto the packing paper without the mild steel plate. So after the pressing process, the desired thickness of sample for fire test is obtained about 1 mm, but for the mature test, the thickness is about 3 mm. So the procedure shows the moisture absorption test, and then this is the procedure show the fire resistant test. So in this study was carried out using a two-step experimental design, which FRFD and the RSM. So there has three factors will be investigated to identify the significance for each. So this is the low level and the high level used to prepare the sample. After that, the RSM is used to predict the optimal composition occur. It is due to the lower density of the geopolymer with the excess concentration used. So the next, this figure shows the optimization block of the effect of the different combinations of factor on the response. So for the optimization process, the 14 NaOH concentration was chosen as a fixed value. This because the amount of silicon, the effect of silicon is more interest as compared to the NaOH. So the next part is RSM. From the contour plot generated by the RSM, we can see the higher of both ratio used, so the lower of temperature and equilibrium can be achieved. There is the same condition for the moisture absorption, so the lower of percentage moisture absorption can be obtained is around 60%. So as the RHA and AA ratio is used, whereby the more RHA content and AA solution is constant, the bonding structure of the geopolymer become more compact and less porous. Then it forms to produce better thermal stability of the RHA geopolymer coating as well. Besides, the interaction between nanoparticles, which is a silicon in the RHA and the silicon rubber, lead to increase in physical and chemical cross-linking points are likely to contribute to the improvement of thermal stability and also resistant to the moisture. In addition, the silicon rubber also is a good hydrophobicity and also can improve the resistance to the moisture. So this is the optimal composition of both ratio can be achieve the best moisture resistance and the fire retardant properties of coating. So next, this the table shows the experimental validation when the sample is the composition of sample is according to the optimal composition. So the average error is below 15%, means that the developed regression model established using this model was able to optimize value for the response accurately. So the last part of result is microstructure analysis. There has several samples were analyzed using a scanning electron microscope SEM. So there is the first sample with good performance before fire retardant test under 1000 times and 5000 times magnification. The figure shows a relative corrugator wrinkle surface developed on the surface. It may due to the improper pressing and cooling process. So at the higher magnification, the sample which contains the highest amount of silicone rubber show a very smooth surface. So the excess silicone rubber form a thin layer and cover the layer of the composite coating matrix underneath. So this is after fire test. The figure show the char resistive, which is a layer of excess silicone rubber is porous and continuous. Although there are small holes located in the residue due to the permeating of gases resulting from the decomposition of silicone rubber, the structure is compact, which provides the shielding effect for the layer of geopolymer composite matrix underneath. So this is a sample with poor performance in fire test. Before the fire test, we can see the silicone rubber is round incorporated into the geopolymer composite matrix. And due to the dominant geopolymer composite matrix, crack and corrugator ringgit were developed during curing and pressing process. So the formation of crack was consequently provide opening, which allowed the heat to transfer further into the layer of coating and lower the fire retardant properties. So this is the sample after fire test. It showed the formation of long and wide crack into the residue. As the coating was heated, the air inside the coating swelled and expanded the cracks. And this because the efficient silicone rubber in the sample does not significantly help in providing the additional protection for the substrate. So this is the sample for moisture absorption test with good performance. From the figure, it reveals that the silicone rubber formed as the outer layer of the sample without any crack formation. And a highly viscous geopolymer composite matrix form this layer with an RHA and AA ratio of 0.85. And since the content of RHA is higher, only a small amount of silicone rubber can be blended with the geopolymer composite matrix, and so the unreaded silicone rubber form a thin layer beneath the geopolymer composite matrix. So the silicone rubber is hydrophobic, so it acts as a parent against moisture. So and then this is the last sample for moisture absorption test with poor performance. So the figure show the crack development on the surface of the coating. So the crack and holes form due to non-uniform mixing during hot pressing and consequently increased water absorption rate. So the gap between the coating is filled with water. The water flows into the adjacent matrix by capillary action and form the damaged zone. In the damaged zone, the water was absorbed quicker than in the undamaged material around the cracked surface. So this is a summary for this study. And then this is a recommendation for further study for those who want to discuss and research about this topic. So thank you for watching my video. Thank you.